In this video, we're going to identify a shape which is similar to another. Now, what do I mean by the word similar? Well, it has a special meaning in mathematics. The word similar for two shapes means that the shapes are the same shape with the same angles, but potentially a different size. So same shape, potentially different size. And a really important property is that if it remains the same shape, all the sides have to scale in the same way, the same scale factor. So for example, if you were to double one length to get the enlarged shape, then the other lengths have to double. The width becomes double, the height becomes double. If the width becomes 3 times as big, the height becomes 3 times as big. So you have to have the same scale factor for all of the sides. Now we want to find a shape which is similar to shape C, which is this one. And as we said, all the sides have to scale in the same way. Now let's just eliminate the ones that really don't look like they're going to be right. It doesn't look like it's going to be E, does it? Because we can see that that length there is the same length as there. But in this shape, in the kind of like inny bit, the alcove, this length here is not the same length as that. So it can't be that one. Similarly, it can't be this one here, I, because if you look in this kind of alcove, the inset bit, that length's the same as that, but that length is not the same length as that, so that one doesn't match, it's not the same shape. It also can't be a G, because again, this kind of inny bit here of the L, like those are the same length, but those are not the same length, so it doesn't match, so it can't be that. It can't be A for the same reason. So it's not that one, can't be H for the same reason, because again, that length's the same as that, but that length's not the same length as that. And it can't be B either. It can't be B because although this length is 4 and this length is 2, just like here, this length is 4, this length is 2, the thing is the other lengths have been scaled. So for example, this top length here is twice as long. This top length of here is 4, this top length is 6. It's scaled up, but these lengths of 4 and 2 haven't scaled up. So it can't be the same shape. So that one's not right. So we haven't got many left now. What about F? What about F here? Well, we can see that this length here is 4. This length here is 3. So these are kind of like outer lengths. These outer lengths here, we've got 6 here and 4 here. Now, that doesn't actually work because can you see that the shorter length here is 4, the shorter length here is 3. So to get from 4 to 3, it's 3/4 of the size. But to get from 6 to 4, that's not 3/4 of the size. So that doesn't work. And you can kind of see that, look, this is just not the same shape as this one. It's not the same shape. So we can eliminate that one. So we've only got one left now. So it must therefore be D, which is here. But if we actually check the lengths to see whether they are actually similar, can you see that these outer lengths are 3 and 2 here? And that is possible to get from these outer lengths of 6 and 4. Because look, if you halve the 4, you get to this 2. If you halve the 6, you get to this 3. So it seems to be the same shape, but just half the size. And if you take this alcove, like this alcove, you've got this length of 4 and this 2, this inny bit. These lengths here are 2 and 1. And you can see, look, the 4 is halved to get this 2, and the 2 is halved to get to the 1. So all the lengths are scaled by a scale factor of half. It's made half as big, and therefore the answer is